So next speaker is Alexandra Kourfali, from Program Manager at EuroHPC. And she will talk to us about, from open silicon to sovereign computing, EuroHPC version for RISC-V.
Thank you. So, hello everyone. So I'm going to talk about, I'm going to present EuroHPC for maybe the few of you that you don't know us yet. And I'm going to talk about open silicon to sovereign supercomputing and our vision for RISC-V. So let's see if this works. Maybe no. Yeah. Okay. So who are we? We are an EU body and a funding entity. We have been created in 2019 and we have been autonomous though since 2020. We are based in Luxembourg and we are almost 50 employees by now. We are still growing, and here you can see a picture of us because most of you interact with only one or two of us, so there is a whole team behind. Okay, no, a bit slow. Okay, so our mission. Our mission is organized around 7 pillars. And this includes the infrastructure, the HPC systems, the AI factories, applications that includes the Center of Excellence, international cooperation with outside Europe, federation and hyperconnectivity for the infrastructure, creating the ecosystems with increasing the skills, and technology that includes the R&I activities on hardware, software stack, pilot, quantum integration, and energy efficient HPC systems. 1 second, I will talk about our infrastructure. So we have a fleet already with 8 supercomputers all around Europe and 2 ongoing systems. We have 8 quantum computers and 2 quantum simulators, and we have recently have been launching AI factories, and we have selected already 13 sites all over EU for AI optimized or AI upgraded supercomputers. And how are we structured? So we are co-funded by the EU countries and private members. So what we do is that we pool resources from all these members, and then this results in billions of euros of investments. And what we do with this, of course, we return it back to Europe with research and innovation projects and our infrastructure. This means that for this MFF, we had 2 billion euros that have been invested in research and innovation projects. And currently, we have more than 40 research and innovation projects running, and they're all centered around technology, applications, and skills. And of course, with this huge investment, we address the whole computing stack. And so we address the hardware, the system software, applications, and we also enable the community by increasing the skills. And we also have summer schools and training programs. And now, I'm going to talk, of course, more about microprocessors. We have a strategy around that we divided in 3 terms. So for short terms is when we have the first IPs, and we build on the European Processor Initiative efforts. And at this point, it's the point that we are now. And we have the first test chips, and we increase slowly the TRL. And at this point, the goal is to have a EuroHPC exascale supercomputer as a first customer. The next, up to 2030, we want new RISC-V architectures to complement the work of our projects that are already running. We want pilots on RISC-V that have standalone competitive components, and then we want a post-exascale system to be the first customer. And after 2030, we have it vague because it changes very, very fast. But our goal is to have post-exascale RISC-V system based on European R&D. And of course, we have noticed that the RISC-V and the AI have been changing the strategy, have been changing technology, and they have been the 2 main disruptors lately. And how we adapt based on that, we have a roadmap. We have the accelerator roadmap that is centered around, again, the European Processor Initiative. And then, of course, we have the CPU roadmap. And The goal at this point is to start maturing the IPs. We have software development vehicles, we have pilots and operational HPC components coming up next, and we want to build more and more European IP and, of course, AI optimized. And all of it is towards the goal of a European supercomputer. And now I'm going to start talking a bit more specifically about our project. So now we already have the European Processor Initiative running for some years now. And EPI addresses both ARM and RISC-V, and we want to go from a predominantly ARM ecosystem to a more balanced solution, and that's where the next framework partnership agreement comes into play, where we are going to invest significantly on RISC-V actions. So at this point, of course, I want to say that we address both ISAs, and we don't consider them competitive, but two complementary roadmaps and two complementary strategies that we have running simultaneously. And at EuroHPC, we have the European Processor Initiative at the front and center of our actions. And as I said, it addresses both RISC-V and ARM. And around it, we are having prototypes, we are having test chips, we are having a new emulation infrastructure that is able to generate new IP and test it and prototype it very fast to create new architectures. And this project also has a lot of focus on skills and dissemination. And as I said, this is at the front and center, so that means that around it we have a lot of other projects that are large projects, and they use a lot of them use the European Processor Initiative as a starting point. And I would like to note the EU pilot, the eProcessor, and the DARE project are all connected and RISC-V based. And here you can see the investments that Europe has made on these projects, and you see that they are significant investments. And of course, they range from 8 million to 240 million euros with the DARE project. And of course, with a lot of money comes a lot of responsibility. And this means that our projects have high TRL, and we expect chips out of our projects, at least test chips. So, where we are now. For EPI, we already are at the second generation of a tape-out. We have the EPAC 1.5 that you can see it is being demonstrated outside. And here we have the software development vehicle that you can see running outside in the booth. Then we have the EU pilots, where here we have two different accelerators, the VEC, that already we have a test chip back that is running, that is now during the at the bring-up phase, and is running as expected. This is Global Foundries 22 nanometers, and now we are at the point of the new tape-outs of the VEC, that includes the semi-dynamics core and contributions by BSC and Forth and 25 other partners, and the MLS with the TSMC 7 nanometers, that is the AI accelerator with a strong focus on AI. And this is also also the platform, guys, that you can see outside. And finally, we have the eProcessor that also has a chip back 5 months ago, and also running as expected, and it's a RISC-V out-of-order core. So yes, and then all these maps, as you see on this roadmap. So we are still considered that we are on the R&D phase, since we are now starting to have our first components, but we will not stop here, obviously. Then at the second phase, we are going towards commercialization. We will build more the IP portfolio of the project and mature the software stack, and all towards the deployment on supercomputers in the future. How do we do this? I will spend the last few minutes of my talk talking about DARE. DARE is our last framework partnership agreement that we have in Europe. As I said, is this 240 million euro action only for the first phase. And here you see how the European community comes together, because you see that there is the know-how and expertise from national programs, from projects from the ChipJU, from all EuroHPC projects, from the DEEP, the RISC project, the Higher project, the Mont Blanc projects that were happening 10 years ago, and all other related projects that spill over into DARE, that is organized in 3 phases. First is the first components, then the pilots, and then finally the procurements. And a few more details about that. As you understand, it's a massive project, so it is organized in 3 different phases, and it is also organized horizontally in technical areas. We have an area that is dedicated specifically to the coordination and roadmap. This is done by BSc. And then we have the hardware areas, where here we are going to have one AI accelerator, a vector accelerator, and a processor. And then we are going to have an integration and prototyping technical area and the whole software stack. And as I said, with the big investments, you have a lot of responsibilities, so the expectations are high for this project. So we are expecting chiplet-based architectures and advanced technology nodes, and by advanced we mean at least 5 nanometers or low. A few more details about the technical areas. As I said, this is coordinated by BSc. The Jülich Supercomputing Center and BSc are taking care of the software stack, and then we have the chiplets, where here we have the technical area leaders that are Accelera with the inference accelerator, CodaSIP with the GPP, and OpenSIP with the vector accelerator, and IMEC that will deal with the backend packaging and prototyping. And of course, you have to understand that this is a project of approximately 40 partners. A few more details. So here, as you see, the accelerator that is going to deal with inference is paired with the general purpose processor of CodaSIP, that they will be in the same system in package. And Accelera is bringing the proprietary in-memory computing. And they are going to create the AI processing unit, and then CodaSIP is bringing their out-of-order core that is customizable and reconfigurable, and then they are going to integrate it on the same. They are like 2 separate chiplets that they are going to be integrated in the same system in package. And then we have a different way to go with a vector accelerator. So here we have the previous projects from EPI and EU Pilot. We have IP from previous projects that is spilling over into the vector accelerator, and here we also will have OpenSIP leading the efforts of the vector core. And then, of course, we're talking about chiplets with advanced nodes that are going to be integrated in 2 different systems in package. IMEC is taking care of that, is leading this effort, of course, as I said, as a part of a consortium with other 10 partners on this technical area only. And here we are going to have an x86 host and multiple other devices that are going to be integrated with, of course, the goal of having a server. And then finally, I will not go through the whole software stack, but I just put the slides for dramatic effects, just to show that we are addressing the whole software stack in this project. We address hardware, software co-design, and we build on European strengths on HPC and AI. And we focus on basically everything. And to conclude, as we said also last year, RISC-V is inevitable. We need inclusiveness in participating in actions from academia and industry. We need cutting-edge technology. We need chiplets. We need advanced nodes. And we need a stable software stack that is extremely crucial. And we need consolidated effort of all projects from all over Europe. And with this, thank you for your talk. My talk.
Hello. Thank you for the presentation. Very nice presentation, by the way. Actually, yesterday I was talking here about manufacturing, and this is one of the things that, we lack in Europe, and you're talking about advanced nodes and things like that. And so when you have a roadmap that is spilling over 2030 to get to the tape out of the processors, where are you going to build them? That's one of the things that, it's one of the key issues right now here in Europe, that we don't have manufacturing for that kind of technology. So do you have any plans for that?
Of course, this is completely above and beyond our mandate as EuroHPC. And also, we don't create policies. So everybody knows that advanced nodes are made in a very specific area in the world and with the most advanced supply chain that exists. So this, even if it was in the plan, it cannot happen with this aggressive timeline. So there is no other option, of course, than use the state-of-the-art infrastructure that exists in only one specific, very small country.
Thank you, Alexandra.
Thank you.
You can thank you again. Thank you.